For those of you, if this is your first time, I've got a slide up about CARC. There's 4 different kind of seminar tracks: data facing, emerging centers, researcher facing, and systems facing. But then there are also working and interest groups that are more centered around deliverables. For example, the capabilities model, which is kind of a complement to EDUCAUSE's annual survey that they give out, and they had their first cohort this year and presented on it a couple weeks ago. Super interesting stuff. Cool, but with that, we can get started on the talk for today. So today we have a little panel-ish. We have Eleanor Cole from HathiTrust. Did I say that right?
You're very close. Kale, like the vegetable.
Kale. Okay, nice. We have Erin McCabe from the University of Cincinnati to talk to us about 2 digital scholarship platforms that they help support. Cool. So I'm not sure who was going first, but go for it.
Okay, I am going first, so let me start sharing my screen. So I have a little slide deck to guide me through as I'm talking, but I'm hoping to invite all of you to interrupt and ask questions as we go through. Erin and I talked to Amy about this on Friday when we were prepping, and I think the same is true for Erin's presentation. We're hoping to keep this informal and conversational. So if you have a question that jumps up as we're going through, please feel free to ask it. All right, so I'm going to be talking about the HathiTrust Research Center and the work underway there to make the corpus of the HathiTrust Digital Library accessible for text and data mining. So you may or may not be familiar with HathiTrust, so I'll do my very quick overview of what HathiTrust is. HathiTrust is the largest nonprofit digital library in the world. It's based at the University of Michigan. In addition to being a preservation repository for scanned materials, it is a member community made up of a partnership of primarily academic libraries, the majority of which are based in the US, although our international membership is also growing. And those members contribute content to the digital library. The HathiTrust Research Center operates alongside HathiTrust. It is co-located at Indiana University and the University of Illinois, although there's no physical center for you to go to. It's a virtual center operated by those 2 campuses and operated out of a few different departments on those campuses. So support is coming through the library schools, the Pervasive Technologies Institute at IU, et cetera. The mission of the Research Center is to facilitate text and data mining of the HathiTrust corpus. So HathiTrust central staff, which are located at the University of Michigan, are primarily interested in reading applications of the digital library, whereas the Research Center staff are interested in computational uses of the collection and some of the affordances that they're made when we allow data-driven research to happen with the corpus. So in terms of the data that we are providing access to for researchers, there are nearly 17.5 million digitized objects. And in our parlance, we call these volumes. And a volume is a single item that could have been pulled off of a library's shelf and scanned. So sometimes that's like a single novel, or sometimes it's a series of periodicals that have been bound together, but it's just the representation of one physical object that would have come from a library, scanned and added to the repository. The data that HTRC makes available includes OCR text that's provided by the member libraries and the digitizers, metadata, and derived data sets. You'll see here that missing from this list is page scans. HathiTrust, of course, does have page scans, but the Research Center does not sync them or provide access to them for data-driven research, although we have made some several sort of one-off allowances for researchers to work with those materials, but we're primarily focused on the text data. And altogether, the plain text, metadata, and derived data sets constitute a little over 150 terabytes worth of data. All right, so sometimes when people think about HathiTrust, they primarily think of it as a repository for public domain fiction, but there's a lot more in the collection than just that. It does include things in the US canon like Moby Dick, but also lesser known works of fiction like the Cubby Bears in California, as well as things like lots and lots of government documents. The example on the slide is this yearbook from the US Department of Agriculture, but there's lots of other kinds of government documents that are sort of better suited for data-driven applications, as well as many works of fiction and nonfiction. Some challenges that we face in dealing with this data and providing access to it are that it grows daily. The scanning for materials in HathiTrust has slowed during the COVID-19 pandemic. There's not a lot of scanning happening in academic libraries right now. But prior to the pandemic, the digital library was growing at a pace of roughly 1 million volumes per year. And so items are ingested into the digital library and then passed on to the research center for data-driven applications. Additionally, for the items that are already in the repository, the data is not static, it changes. So sometimes scans are updated because the scan itself was poor. Much of the material that's in the digital library was generated using mass digitization techniques, which means that there's not always sort of like a careful eye paid to how things are going. There's lots of quick page turning happening. So occasionally you get a hand in the scan or sort of blurred images. So sometimes those are updated, or the images can be re-OCR'd. So if you know much about OCR, you'll know that it has improved a lot with time. It continues to get better. So things in the digital library that were scanned sort of at the start of HathiTrust around 2008, the OCR tends to be of worse quality compared to things that are scanned now. So things do get re-OCR'd. And this creates challenges for us in terms of how researchers are able to communicate their results. And then finally, and this is a big piece, is that much of the content in HathiTrust is under copyright. So it's not just, as I said, a repository of public domain fiction or even of government documents, which are largely out of copyright. There's much material in HathiTrust, in fact, almost 2/3 of it, which isn't available for human reading. And this is where the Research Center comes in with its approaches for providing access for data-driven research. So we have a 3-pronged approach for how we provide access to the text data for research applications. And we operate under a paradigm that we call a non-consumptive access paradigm. Sometimes non-consumptive is also called non-expressive uses. That's of course a nicer term, but we've really stuck our flag in the sand with non-consumptive, even though it has a harsh sound. And this is what we mean by it. We mean that it is research in which a researcher can basically do data-driven research using the materials. So text and data mining, OCR correction, automated search, things like that, but not research in which they access the materials for human reading of the expressive content of the underlying text. So we have all of this text that exists in our data set. We can't make it available for the human reader, but we can make it available for the machine reader. And we have, as I said, these 3 ways of making the data available. There's what we call a partial model, a transformative model, and a capsule model. And I'll walk us through each one of these. So the partial model primarily covers our web-based algorithms and visualization tools. So using these tools, the researcher doesn't have access to the underlying data, but they can sort of point and click and say, I would like to analyze this collection of materials that I have built with this tool, and then the results are output for them. That means that the researcher has less control over the process than they do if they're sort of building a tool themselves. Of course, it's an off-the-shelf tool that's always at play, but it's even more acute in our environments because they don't have access to the underlying data. So we envision these tools as being best for the researcher who's just getting started, for students, for people who just want to poke around. They can do things like track word trends in the repository over time, create a word cloud of word frequencies in a collection, do some basic named entity recognition, and also do some topic modeling. The data that are used for these web algorithms includes both the public domain and the in-copyright corpus. And because none of the data is being exposed to the researcher, then any researcher is free to come in and use these tools. Additionally, I will mention that HTRC uses a term internally and externally, but this is not a term that's used in the wider world, which is this idea of a work set. And with these work sets, they are essentially the collection that the researcher uses to do their analysis. What makes them distinct in our parlance from a data set is that, say, when you download a data set, you're downloading the data. When you download a work set, you're downloading the metadata about your collection. So when you build these collections for analysis, again, the researcher doesn't have access to the underlying data. What they do have access to is the metadata to sort of select, I'd like to use these 150 or 3,000 volumes and plug it into this algorithm. So that's the partial model. The data is more restricted, but the output is open. The next model is the transformative model. And this is the model by which HTRC provides access to data from HathiTrust in the form of derived data sets. The primary derived data set that we make accessible is called the extracted features data set. It's a JSON data set where there is one JSON file in the data set for each volume in HathiTrust that has been rendered in this format. So there's 17 million volumes in HathiTrust. There are 17 million JSON files in the extracted features data set. Researchers, generally speaking, aren't using the entire extracted features data set. It's several terabytes large. They're not downloading it and working with it locally, although some researchers are working with the entire set. Most people are picking and choosing files from within the larger data set. These files consist of bibliographic metadata about the volume that they describe. So that's what you're seeing on the slide is some bibliographic metadata from this text called zoonomia. Then there is also metadata about every page in the volume. And so this is metadata like what is the language of the page, how many words appeared on the page, how many sentences, how many of the lines are empty, which can sort of hint at whether you're looking at a page that has is full of text or is only half full of text, which can give you clues about the beginning and the ending of chapters. It also has metadata like what are the characters that start and end the lines, which can hint to a researcher whether they're looking at a page of full text or a page of an index or bibliography, or looking at poetry or prose. And then the meat of the files are words and word counts for every page in that volume that's being described in the file that have been tagged with part of speech. So you'll see every word that appeared on the page, the part of speech, and the number of times that it occurred. This data set allows researchers who are using sort of bag of words type methods to access the data, have some of the pre-processing done at the outset without having them repeat processes, and without them having to go back to the full text. And it allows us to open this data widely. It's freely available to anybody who wants it, but it's not a good data set, of course, for reading because the words are out of order, which is sort of the point here. But it's also not good for researchers who need the words to be in order to do their analysis. So researchers who are using methods where it's key that from the outset their data have the words in order will find this data set to be useless. But the researcher who needs words just to know that the word occurred on the page, so applications like topic modeling are often like this, or some kinds of machine classification, you can do really interesting work with the data that's made available through the extracted features files. Additionally, we have some other derived data sets that we've partnered with researchers on and made available, including one that's based actually on the extracted features data set, which was a genre analysis of the HathiTrust Digital Library. And it provides access to words and word counts by year for different genres in the digital library. So fiction, poetry, and prose. And so, is that right? fiction, drama, and poetry. I think that's actually what it is, which would make more sense. So a researcher can come to those materials and not have to recreate the steps to have access to those words and word counts if it would be helpful for their research. And also it creates these nice lists of all of the fiction in HathiTrust, or all of it as was discerned by this machine learning algorithm for other researchers who want to build on that work. The other one that I'll mention of these derived data sets is a geographical entities data set from a big NER project that was carried out over 5 or so years, which has all of the geonames in fiction and HathiTrust, plus some additional metadata about those geographic names. Okay, and then the third prong of this three-pronged non-consumptive research approach is the capsule model. So the capsules are different from the extracted features files and from the algorithms in that the data is less obscured to the researcher when they're in the capsule, but access to the data and the data that can be exported from the capsule is tightly controlled. So if you're familiar with a secure data enclave, this is similar to that model. A researcher can provision themselves a virtual desktop that looks like what you're seeing on the slide, which is an Ubuntu desktop running at IU. And then they have control over that virtual machine, much like it was their own computer. They can work with their capsule in 2 modes. In the first mode, which we call maintenance mode, they have access to the network, so they can install software, they can bring in outside data, and then they can switch their capsule modes to what we call secure mode. And all of that setup that they did on their machine is still there, but the network access is cut off, and the connection is opened up to the HathiTrust data, to the data that HTRC provides access to. So the researcher can then download HTRC data and run their analysis. The data is not pre-formatted in the same way that the extracted features data set is. But when the researcher is ready to leave the capsule, the only data they can take with them is the results of their analysis. So that will look like derived data. It might look like the results of doing topic modeling. It might look like words and word counts in sort of a basic sense. It might look like a language model, that sort of thing. That data goes through human review before it is released to the researcher. So it's a much more tightly controlled process than the other 2 systems, but there's a little bit more flexibility and freedom for the researcher to do the kinds of analysis that will be most beneficial to their research. Again, they're not a reading platform, so the researchers are obligated and agree to terms of use that they will engage in research practices in the capsule that comply with our non-consumptive use model. Okay, so this is what our 3-prong approach looks like if we're thinking about it from a more infrastructural view. I've lost my mouse. Okay, I have it back. All right, so as Deb hinted at the beginning of the presentation, HathiTrust has this massive data store. The primary set of that data lives at the University of Michigan. IU has a backup copy. And when my colleague Aaron talks to you in a few weeks, he will likely talk about that backup copy. And then on top of that backup copy, there is an additional copy of the data set that also lives at IU that is used for HTRC. We sync data nightly from HathiTrust Central because the repository is growing daily. So we do a nightly sync to make sure that we have the most up-to-date data. The data that we bring over can be converted into those extracted features files under the transformative model. Some of that data, the extracted features data, actually underlies one of our off-the-shelf tools, which is called HathiTrust Plus Bookworm. But the other HTRC algorithms have the other data from HathiTrust fed into them. That data also goes into the data capsule environment. And then I should back up for a second. I forgot to mention that the data capsules can have access to the entire HathiTrust text corpus. They do not have the functionality to allow a researcher to work with all 17 million volumes. It would be too much data to bring into one of our capsules. They're not that powerful. So most people are working with a subset of the data. Additionally, by default, the researcher only has access to the public domain corpus from HathiTrust, but through an application process can have access in their capsule to both public domain and in copyright data. Okay. All right, so I'll talk about a few other challenges that we face in providing access to this large data set. The first is in supporting researchers, and this is one of my primary roles with HTRC is leading training and outreach, so it's something that is top of my mind when I'm thinking about challenges that we face. So one thing that I have observed in recent years is that the gulf in skill levels is getting bigger. So when HTRC was founded around 2013, it seems to me that the novice user and the more experienced user of our tool set, which are primarily researchers in digital humanities, there wasn't a lot of space between those two people. If you had interest in a DH tool, then you likely had some minor skills in order to interact with the tool. What we're seeing now, or what I'm observing now, is that researchers who have some interest in using a text analysis tool might have no experience whatsoever, and our advanced researchers are continuing to get more and more advanced. So they no longer want to do basic topic modeling. They no longer want to just sort of like render a graph very easily in one of our tools. They want to apply really complicated language models. They want to work with lots and lots of data. And that challenges the support that we're able to give them, both in terms of consultations and expertise on our staff, and also in what they want to be able to do with our tools and systems. And that's what I mean by new methods and techniques, is that the boundaries are being pushed constantly in the field. And so as the advanced researcher gets more and more advanced, they expect our tools to keep up. And so that creates a challenge for us. Additionally, there's a challenge in terms of building collections. There are metadata challenges. So the metadata that we get comes downstream from HathiTrust. Some of the MARC metadata can be a little messy, can be a little funny. So trying to help researchers find the content that they need within this massive digital library can be a challenge. And then also we have developed different search mechanisms for accessing the content and sort of picking out what you need. But researchers want to write really complicated queries. And I think that we have struggled to find ways to make that possible. Okay, we are currently embarked on a project that I wanted to mention that's called SQUARED. Yes, that's how you pronounce that acronym. The Scholar Curated Work Sets for Analysis, Reuse, and Dissemination project. This is funded by the Mellon Foundation. And the goal of the SQUARED project is to build what we're calling reusable illustrative research models. Basically, we are working with a selection of researchers. We have a handful of projects this round of support that we're offering. So the researchers will build out these work sets, which again that's just the HTRC language for a collection of data collection on a specific topic, discipline, or theme. They have to be related to a marginalized textual community, and I'll show you a list of our projects in a second. And so then in addition to this work set that they're building, the collection, then the researchers will also be writing scholarly introductions to describe the work sets that they have built. They'll be performing some analysis with our support. They'll be writing white papers about their analysis, and then they'll be creating derived data sets in the fashion of our extracted features files that might sync up with extracted features files based on the work that they have done. So the projects that were selected under the larger SQUARED program are listed on this slide. They're really exciting and interesting. The flagship project is called Project on the History of Black Writing / Black Book Interactive Project. That's with project co-PI Mary Emma Graham. And then there are 4 additional projects, one looking at Native American authored works in HathiTrust, one looking at the Black Fantastic, which I'll talk more about in a second, one looking at Latin American fiction, and then one that's looking at African American health periodicals in HathiTrust. So the example that I wanted to sort of call out was the way that we are working with researchers in the BBIP group, the Black Book Interactive Project group, and the Black Fantastic group. to sort of align their bibliographies with the HathiTrust corpus. So this doesn't sound like a particularly difficult problem, but it turns out that it is actually quite hard to match up just a list of author and title pairs against the digital library, because those author title pairs are sometimes formatted in unique ways, and then our metadata can be sort of strange. So we have the HathiTrust corpus, and then we have the BBIP corpus, which is a bibliography of African American authored works, some of which, about a third to a half, we've been able to locate so far in HathiTrust. And then what we're doing with the team, the Black Fantastic team, is working from those volumes that are in the Black Book Interactive Project bibliography, locating them in HathiTrust, and then we're going to be able to apply some new and novel techniques for finding other books that would likely fall under the genre of the Black Fantastic, using the seed texts that we know are Black Fantastic books to sort of drive that discovery. So we'll have this larger list of the BBIP corpus. We've narrowed it down to the BBIP corpus just in HathiTrust, and then we'll narrow it further to those books on the BBIP list that are in HathiTrust that are part of this genre called the Black Fantastic, and then we'll use those texts to go out and do this seed search based on similarity measures to see if we can identify works in HathiTrust that may not have been recognized as part of the Black Fantastic. And the researchers are hoping to do some interesting theorizing about the nature of this genre called the Black Fantastic. So when did it start? Who are the contributors to it? That sort of thing. Okay, so that is the end of my presentation, and I will turn things over to Erin now. Stop sharing. Okay.
That might make for a great transition, because I think Erin actually has a question for you, Eleanor. So Erin, if you want to actually ask your question, unmute and ask your question, that'd be great.
You were on a roll. I didn't want to stop for a nitpicky thing. The human review element from Capsules, I thought sounded like a lot of work to me, but maybe I'm misrepresenting it. But is there a limit to how many capsules HathiTrust gets involved with at a time, or what does that human review process look like? Man,
we haven't put a limit on the total number of capsules that can exist in the system, although there is a practical limit. We haven't hit it. We have a limit on how much of our resources an individual researcher can use in terms of the number of capsules and how the capsules are created. And then we also have guidelines in place for what we will review. So the files have to be smaller than a certain size. They have to be non-binary. Let's see, I'm trying to think if there's anything else here. That's it. We do promise to get things back in about 48 hours. Sometimes there's a longer review process that needs to happen when the files get particularly large. But for the most part, the data that's being exported should be simple enough to review that it goes relatively quickly. Sometimes if it's a really long file, it's a lot of scrolling, but it should sort of look like derived data.
that makes sense. Cool.
I guess, Erin, before you get started, are there other questions for Eleanor? I don't see any in the chat. And we'll have time at the end of Erin's presentation again to also address questions. So it's all yours then, Erin.
Excellent. It's pretty hard to follow up the Black Fantastic. That sounds so cool. But I'm going to talk today about the DSC's platform. Once I get this started, I don't want to take up too much of my time giving you all definitions, but I do think it helps to kind of have a little like you are here mall map type of moment, so that we can see that we are in natural language processing in this larger realm of AI. And like Eleanor, we're focused on text mining and analytics. So NLP, where we live, or where I spend my research. It has, a cornucopia of other tasks included in that as well. Things like, your smart assistant or Google Translate or whatever. But we're going to be focused on just text mining and analytics, which is tasks like what Eleanor was talking about. Like finding patterns is a huge preoccupation in this unstructured text data set. So we're the green dot right here. Okay. I think I'm going to kind of, sorry for the jarring here, but I want to show the actual platform itself. This is, the research I do is predominantly done in the DSC's own platform that we've built with Mellon funding as well. And it looks a little like this, or it looks exactly like this, where you can select a data set that you want to work with. To Eleanor's point about copyright, we do have text. We don't work in a non-consumptive approach, so everything you will actually have access to the text itself, which obviously limits our database options or our data set options quite a bit. You can search within a data set with terms and date ranges. This is for a data set of case law that's made digital by Harvard and their CAP program, Case Law Access Project. And I'm looking for antitrust and market power here around the years of Reagan. You can, like I said, explore your documents in the next step and take a closer look at some of those. This is where the text is actually reproduced. And then we get to choosing your visualization and model type. So the DSC's platform really is this topic modeling focused platform. I'm going to skip over the Word2Vec explanation. It's a little bit like the ugly stepchild or something of our project so far. The other 3 visualizations, though, are all based on topic modeling. So that is kind of a natural kinship among the other 3. PyLDA Viz and Topic Browser will maybe look familiar to some of you. These are some of the more out of the box, off the shelf type projects that have been around for a bunch of years. And they're both based on that LDA topic modeling. But I'm going to spend the majority of our time today talking about the multi-level model of models, which is the DSC's like central innovation on this platform. So while the model of models, the multi-level model of models, affectionately known as the MLOM, is also based on LDA topic modeling, what this one does is generates 6 different topic models and then kind of concatenates them, which allows for us to have some additional stability to topic models, as well as give us a hierarchical view of our topic model structure of the data set. So before I get too deep into that LOM talk, I wanted to quickly, broad strokes, talk about LDA topic modeling, which is the foundational model to all of our visualizations, except for Word2Vec. So again, I'm sure some of the people listening are already familiar with topic modeling, but the type of topic modeling we use is based on this one big idea that words that frequently co-occur across a high number of documents in your given data set are going to be part of the same topic. So that means that a topic is really just a list of frequently co-occurring words like market, merger, monopoly, competition, that kind of thing. And it won't have this label like antitrust topic. The next thing to keep in mind is that documents contain multiple topics. So it's not, a Harry Potter type sorting hat. There's no mutual exclusivity there. So they'll have multiple topics and at different percentages. I think of this sometimes like a document's particular thumbprint, their exact combination of topics. A document is the exact combination of topics. So on the multi-level model of models, on the platform, looking at the multi-level model of models, we see something like this. And this link up above, you can follow too as well if you want to actually interact with an exact model, because this is an interactive platform. And you'll see this hierarchical structure that I referenced earlier. So on the left-hand side, we have the topic clusters. And on the right-hand side, the next level down on our tree, or next level more specific, the topics that make up those clusters. So we ran 6 models at 40 topics. So quick math, we should have 240 topic nodes here on the right-hand side. So interacting with the cluster chart will populate, or will highlight rather, the cluster that you're particularly interested in, as well as on this left-hand side, our document viewer. So unlike the HathiTrust program, we don't have access to any data that is within copyright. So we are limited in our data set selection by that consideration, because we do reproduce the actual document here on the left-hand side. The major upside to this, however, is that you can kind of, as a researcher, get this opportunity to re-engage with the document. So you can kind of check your assumptions about topics or topic clusters and really get into exactly what you think you're seeing in the topic model. This is like a really good opportunity to ground your understanding of what's happening in the model itself. Let's see, oops, sorry. So we can use this to ask questions like, the word pandemic, given this COVID-19 data set, what types of topics does it appear in? What is it absent from? What is the context pandemic occurs? What is the context, China occurs in? Things like that. We can also look at it with a different visualization, the network visualization. And I want to stress here that this is the same model, the same multi-level model of models. Sorry about the sirens. This is the same model, just visualized differently. So we still have all the same topic nodes that we see in the tree visualization, in the network visualization, just mapped out differently. And interacting with this cluster chart will still populate the visualization as well, or will still highlight the visualization as well. What this visualization allows us to see, however, and I'll make this a little bigger, is the interactions between the topics. So while each topic node in our network is one topic in our model, the edges between them are generated by how many documents those 2 topic nodes have in common. So these 2 topic nodes co-occur in n number of documents. And you can see the stronger relationships by interacting with this slider. So the strongest, most frequently co-occurring in a document topics will be all the way to the left. Okay, this is a bit of a crash course. So I did include links to the models itself if you want to interact. I think there's something to be said about kind of marinating in them a bit. One thing I wanted to call out though, for this network is that it can answer questions about relationships, but also give you a global perspective of your data set a little bit. And what we found for this project specifically was that in the COVID-19 data set, where we have this somewhat triangular network visualization, oh good grief. We can actually see the hydroxychloroquine island acting out separately from kind of the 3 central vertices that we see across all of our viral outbreak networks. So there's a lot of interesting work and things you can pick out given the 2 different visualizations. Okay, so I wanted to talk about some other example approaches. We saw the single model example with the COVID-19 network and tree, and you can spend just hours and hours of time investigating an individual model. There's a lot of researchers that move to model comparative analysis. So how does the COVID-19 model compare to a model for HIV literature or SARS literature? The other consideration would be across time. So in the antitrust example, I kind of included pre and post Reagan era antitrust law. That's one way of looking at it. And then there's also additional DSC work being done in parallel modeling. So to a certain extent, the topic model, the multi-level model of models is somewhat a parallel modeling approach structure already because it's running 6 models starting at different seeds. But we also have, what's the word? We've also conducted research projects with other algorithms or comparing our topic models to a hand-coded system. And that kind of allows us this opportunity to reach a type of consensus research answer. So that's been really helpful. And another example would be using our results from our model to inform some other model. So for example, we built a word-to-vec model, and then we used the terms we were uncovering from that to build our own classifier as like an additional step to that research question. So I think my challenges probably pretty neatly mirror what Eleanor spoke about already. To no one's surprise, data is always a huge problem at this type of scale. I've come across all sorts of weird data problems. Each project has its own funk. That's messy stuff, just really weird data. I think, people aren't considering how it'll be used, so there's not uniform metadata or anything like that. Some data ends up costing money, a lot of things from the business realm, missing and incomplete data. And then the flip side of that data problem is exporting results from our platform. Right now, that's really tricky to do. And once it's done, it's also really hard to make reproducible and transparent to other researchers or just to support our own research publications. Like Eleanor, we have some pedagogy struggles. I kind of consider this like a huge spectrum of people that we work with, from everything from what I think of as like the proud Luddite to, the full-blown robot people who will know 10 times more than I'll know about BERT or something else very complex. And then everyone in between that. We do a lot of interdisciplinary work. That's really a primary goal of the DSC's direction. And that can be really inspirational team science stuff, but it can also end up feeling a lot like herding cats. And to that end too, it's a question of how deep we want to go given a group. You can kind of use the platform a little bit like a black box setup, but we can inevitably go deeper and deeper and deeper into fine-tuning things like specific stop words or specialized n-grams, hyperparameters for our topic modeling algorithm, how many topics you want to break your model into. There's a lot of different ways to get deeper and deeper and deeper. And so with all those issues becomes the issue of scale. I think that's kind of across the board issue with things like that, with things like this. And yeah, I would just say that I think the answer to kind of all of these is something like adaptability, but that often requires knowledge at a really agile level, and time and funding and patience, and not all of those things can kind of co-occur at the same time. A quick review for everyone. I also included some resources, including the pandemic article I referenced in this. And last but not least, just because I'm a strong believer in the time-honored tradition and including a comic book strip in your presentation slide deck, I'll leave that here as well. I think that's everything. It's a little rushed, but I'm here for questions.
We did have one from the chat.
Yeah.
Could topics be considered labels or keywords, or is topics indicating a specific distinct use?
I can answer the first part of that question, but I'm not sure I quite understand the specific distinct use. Oh, I see what you're saying. So a topic here is a list of frequently co-occurring words in your data set. So I think the example, it's really just a list of words. It's not a label or a keyword. This is the part that really requires a humanistic inquiry element where, given this list of words that frequently co-occur in your data set, how are you interpreting that as the researcher? So it's not a label or a keyword, it's topics. I guess it's the second part of your question, a specific distinct use to topic modeling.
So I guess kind of the assumption is if they frequently occur together, that means it's probably one concept.
Yes, exactly. That is like the foundation of LDA topic modeling, that assumption.
So Erin, I'll ask a question, and this I'm asking because I have this specific need in mind. You talked about, or I think you did, talked about reproducibility in the research, and I wondered, is there plans to add in the ability to assign a DOI to a particular data set if you're going to expand certain data sets that are in the system, because you are usually collecting from a date to a date. So if you add into a data set, are you able to distinguish what was the first part, and then how, when you made it dynamic, what did you add in to make it different for another distinct DOI, something like that? Are there any plans for that to help with if somebody wanted to go back and refer to the particular set of articles or that were analyzed, or the set of text that was analyzed?
Yes. So currently our workaround for the exporting situation is to just pull your model's background data from the back end of our server. That is obviously not the most streamlined process. We still are in development. That is the workaround. And then we push that to, Amy, you're familiar with this, Scholar, but that's our digital repository here at UC, which also will assign a DOI to, and now I'm not sure if the DOI is at the data set level or if it's at the whole Scholar repository object level, but one of those. But yeah, the function to export your data, with like a button click or whatever, is on our dev site wish list.
That's good news.
Not so close to the top though, Amy, so.
Okay, I won't hold my breath, but I will look forward to it when it happens.
But yeah, the dream is to make that really sync up nicely with UC Scholar. Just right now it's a little clumsy.
Is this open to anyone?
Technically, yes. You do have to make an account. It's at modelofmodels.io. I'll put it in the link. You do have to make an account, and you can only access the data sets that are there. You can't upload your own data set right now. But I think, but if you want to interact with the actual data sets that are already there and live, it is open to anyone who wants to make an account. If you run anything really huge, it might take a minute, but yeah. That's why our data set collection is kind of wonky right now, because it's completely driven by research projects that come our way. So it's a little bit eclectic. I think of it like boutique research services. But you'll see a lot of fun stuff in there.
What language are you using for the visualizations? Like Python?
Oh, sorry, yes. I was like, English? Sorry, yes, Python. And there's some, the visualization also relies on some Java. But Python is doing the computational heavy lifting. Oh, and Marjorie, the visualization export problem I was referencing was really more about the background data to the visualizations. The data images themselves are a separate exportation wish list. I don't know if anyone's worked on Tableau, but there's a, you can export an image file from Tableau, and I think something like that would be helpful as well, if not the full background data. So it's kind of a two-part export system. I had a question for everyone if they thought, if they have any kind of dream data sets they'd want to use to build out. I always like to ask people what weird things they're into when it comes to text as data. Because I think I've used as example cases a lot of Project Gutenberg data sets. That's always like a fun thing to tinker around with, and open access. Election coverage, yeah. News media is tricky sometimes because that's a lot of copyright stuff. I think I did like CRS, the Congressional Research Service, has reports that I have on my short list of things to upload to our platform. Yeah, tax informations for EIN, Rebecca. Thank you. MPO shout out.
What is the most used data set in the HathiTrust?
Yeah.
I think the one that has had the most sort of traction and reusability is the work that I mentioned in one of the derived data sets that we help support, which is the work by Ted Underwood to identify fiction in the digital library. So that has seeded a lot of interesting work. Like some researchers recently tried to use that list to then go look for speculative fiction in the digital library. And then other researchers have been able to base their fiction analysis on that set, because actually it's not cataloged. It's not like a mark cataloging term whether something is fiction, which always surprises me even as a librarian, that it's not well spelled out in the metadata. So it took this big machine learning project to figure out even what was fiction. But that one has had a lot of legs because it has facilitated other carry-on research.
Yeah, I think we have like a kind of dead data set in our collection now that we tried to pull from Library of Congress. But it does draw a lot of eyes. I think when people first come on, a lot of times they click on it because it's cannabis news, and that sounds really interesting. But then when you get there, there's so, like, as Eleanor, you were talking about the OCR quality for chronicling America, especially because it's newspapers, which is tricky. And it's also really old newspapers, which makes it tricky for OCR as well. It's just so much gobbledygook that it's essentially a completely useless data set now. But everyone clicks on it.
Truly clickbait then, huh?
Yeah.
So I think we're at time. Deb, do you have anything else to?
Nope, that's it. Thank you everyone for coming.
And thank you, Eleanor and Aaron, for presenting, and hope to see everyone next month for the data feminism session.
Yeah, sounds good.
Thank you.
Thank you.